Chapter 3.6, Compounding Interest Problem. Section 3.6 in our book has to do with the exponential functions portion of the book, and specifically with finance. And these problems are going to be involved using a couple different formulas, one of which is listed here, the compound interest formula. And that is the amount equals the principal, this capital P is principal, times the quantity 1 plus R, and R is rate, over N to the power of NT. Now, sometimes you'll see N can be substituted for K. Like in our book, K is what is used instead of N, but it amounts to the same thing. But basically, you're really talking about our standard formula for exponential function we had before, which would be amount equals the principal times quantity 1 plus R to the power of T. And all the compounding does is it takes this R and divides that by N, and takes this T as the exponent and multiplies that by N, or instead of N, K. In addition to this, there's the compounding interest formula, which the continuous compounding. And for all these problems, I want you to use this formula as well. And you're going to see that you're going to get more interest made with continuous compounding. And that formula is going to be amount is equal to P times E to the power of T. Well, it's going to be NT. Okay, and that'll be the number of years, excuse me, be RT. The rate times a T, and rate is not to be in percentage. So this RT, the product of R and T multiplied together, is the exponent of E. And E is this Euler's number that we talked about a couple weeks ago that has special uses in finance and in calculus. And just for context sake, E is approximately equal to 2.718 and so on. So let's go on to our problems. Solve the story problems with assuming no deposits or withdrawals. Heather received $100 for her 13th birthday. If she saves it in a bank with 3% interest compounded quarterly, how much money will she have in the bank by her 16th birthday? So we're going to go ahead and use the formula. And for that, we need to figure out what T is. Well, T is going to be equal to her 16th birthday from her 13th birthday, subtracting 13 from 16, so 3 years. And so T equals 3 years. In the formula, amount equals the starting amount times 1 plus rate over N to the power of NT. So for quarterly, that equals, that's an N equal to 4 times a year. So applying this formula, we're going to have amount is equal to $100 times 1 plus, now R is going to be equal to 3%, which equals 0.03 as a rate. So we're going to put R 0.03 over N, N is 4, to the power of NT, which is 4 times, and T is 3 years. So now we can go to our calculator and put in 100 times, we're going to open parentheses here, 1 plus, we have the fraction here is 0.03, and we're going to divide that by n, which is 4, and we're going to come outside here and take this to the power of nt, which is 4 times 3, which is really 12. And so we get $109.38. And so that's going to be our answer. Now we're going to look at compounding continually, which is going to be A is equal to P e to the RT. So coming back to our calculator, we have 100 times, we have e to the power of rate, which is 0.03, times t, which is 3 years. And so we press enter, we get, in this case, $109.42. Okay, so 100 e to the 0.03 times 3, and that amount is, looking back, $109.42, 49.7 cents. Okay, look, you know how much money compounding interest continually versus quarterly would have made Heather? 4 cents, $109.42 versus $109.38. Those numbers are going to be quite close. Next auditor problem 3. The cream company has an employee savings plan. If an employee makes an initial contribution of $2,500 and the company pays 5% interest compound quarterly, how much money will the employee have after 10 years? Very similar to the last one. We have n is equal to 4, and t is equal to 10 years. So just employing our formula, we have amount equals our principal, which is $2,500, times quantity 1 plus, and R, it's 5%, so 5%, R equals 5%, which equals the rate 0.05. So here in the formula we have 0.05 divided by 4 for quarterly, and we have 10 years, so that's going to be n, which is 4 times 10 years. And so we go to our calculator and put in $2,500, a starting amount, times, we have 1 plus, we're just using the formula, we have 0.05 divided by 4, and we come over here to the right, we go to the power of, we have our n times the amount of years, which is 10 years, and so we get this amount, $4,109.05. And for compounding continually, let me go ahead and put the dollar sign here. Hang on. Compounding continually, we have amount equals E, or principal times E rather, E to the RT. And so in this case, we're going to have amount is equal to 2,500, E to the, and R is 0.05, and T is 10 years. So here in our calculator, we go to 2,500 times E to the power of 0.05 times 10 for 10 years, and we get $4,121.80. Okay, in this case, comparing the quarterly, which is $4,109.05, versus the continually, which is $4,121.80, we get probably about $11 or $12 more by compounding continually with this formula with the E, Euler's number. I'm going to want you to do the odd number problems with the video, but for the even number problems, for yearly, we have yearly, daily, and the SY is different. So in yearly, we have N is equal to 1. And for daily, N is equal to 365. So just like problems 1 and 3, but use 365 for N instead of 4 for N. And then you could use a common one compounding is 12 for monthly. So that's just a little hint. Now problem 5. Carmen is saving for a new car that costs $15,000. She puts $5,000 in an account that earns 6% interest compounded monthly. How long will it take for her to save enough money to buy the car? So in this case, we have N is equal to 12 for compounding monthly, and we have the equation A equals P times 1 plus R over N to the power of NT. And so just substituting in, we have our final amount we want to get is $15,000, and that's equal to our starting amount in the account, which is $5,000 times 1 plus, and we have 6% interest, so 6% is 0.06 over, and we're compounding monthly, 12 to the power of 12 times T, and T is our unknown. We don't know this. And so we could go ahead and gradually solve for this. We divide both sides by $5,000. So if we do that, I'm just going to set this up. And we get 15,000 divided by 5,003. So we get 1 plus 0.06 over 12 to the power of 12t is equal to 3. And basically, what we can do with this is we would have this 1 plus this 0.06 over 12 to the power of 12t would be like a base of an exponent. So we could find out what that is and set that as a base or exponent. I guess I've kind of gone down the path already, so I'm going to have to go ahead and do it. And so the base of that exponent is going to be 1 plus Okay, we have 0.06 divided by 12. Okay, so that's going to be 1.005. So going back here, we have 1.005 to the power of 12t is equal to 3. Now changing this to a logarithmic equation, we're going to have log base 1.005 of 3 is equal to 12t. So solving, if we divide both sides of the equation by 12, we have t, I'm just going to come up here now, t is equal to log base 1.005, see that 1.005 of 3 over 12. So let's go ahead and do that with a calculator. We have control log base 1.005 of 3, and we're going to divide that by 12. So we get 18.356. Okay, guys. This means 18.356 years. That's how long it's going to take Carmen to save for this vehicle. That's not going to work too well because inflation is going to make a new car in 18 years later go up in price probably anyway. Now another way you could look at this is, I want to use that insolve thing. I want to do the, if we compound continually, how would that be different for Carmen? So if we had A equals P e to the RT, we'd have $15,000 equals 5,000, which are principal. We have e to the r, and r is going to be point, what was it, 0.06 t. So I'm just going to go put this in the calculator using insolve, and we go to menu 3 algebra, numerical solve, and the equation is 15,000 is equal to 5,000 times e to the power of, we have 0.06 for 6%, times, we'll say x, and we're going to go ahead and calculate what x is. We press comma and x, and we get this, we get 18.31 years. Okay, so t equals 18.31 years. Okay, you see that t for compounding monthly was 18.356 years, and for compounding continually 18.31 years. So a little bit more quickly she will have saved that accumulated $15,000. So that's, she's going to have to probably come up with some kind of other plan to be able to buy a new car, or maybe settle for an older car today. She's probably going to need, it sounds like she wants to have that car within the next year or two, so she's going to have to come up with a different plan. But mathematics is what allows her to be able to figure that out. Good luck on the remaining problems 2 and 4, and thanks for viewing.